Hey everybody, how are you doing today? My name is Thomas Sneald. I am going to show you how to set up dead zones and sensitivity curves in Microsoft Flight Simulator for our controller, the Yawman Arrow, although you can actually apply this knowledge to any flight control device. When you buy a piece of gamepad or flight sim hardware, there is going to unavoidably be very small variances between one controller to the next. And there will also be instances where every time you use a control, it's going to center not exactly in the same position every time. Although our zones are going to be very, very small, which we call a dead zone, where we expect the center to land when let go for centering controls like the thumbstick or the trigger system, as you see right here. You might find yourself wanting to change how the flight sim handles that variation, or maybe you just have preferences on how sensitive and touchy the controls are versus having the controls be much softer and slower to respond to change. Again, it really depends on your taste, and that's what I'm going to show you how to do right now. So inside Microsoft Flight Simulator, which you see I've fired up, you're going to go to Options. And in Control Options, you are going to see whatever flight controls you have plugged in, including your keyboard and mouse. As you see here, it's picking up the Yawman Arrow right here. And we'll walk through how to use the controls in Microsoft Flight Simulator later and what each of these profiles do. So we got default and two different mappings for hat versus wheel trim with a more advanced profile. But what we're going to focus on today is this button right here called sensitivity. And what you'll notice here is that when I move any axis, an axis is a control that has a beginning and an end, essentially. It's a range. So like a slider, for example, that is an axis. So when I move this pole in and out, or when I move this slider, which I have to scroll down to see that right here. So if I scroll down here, you will see the slider, these two sliders right here. So the sliders, you'll notice that these curves right here, they default as a straight line. And for sliders, a straight line is okay, meaning that for every input, every position we have the slider, it's going to give that exact output from 0% to 100%. That is what the flight simulator is going to read. So it has a straight linear mapping, meaning that it's not going to do anything to change the output. But there are some controls where we might want to manipulate this curve so that it ignores certain positions. It doesn't consider it an input, or maybe we want it to be slower to respond to that input, depending on how far away from the center you are typically. So let's look at the joystick first. So when I move the joystick around, yeah, it's moving around my cursor too in Microsoft Flight Simulator, but you'll see that if I move the joystick in the X direction, horizontal, you'll see that that dot right here does not always exactly fall in center. The same thing with when I move it in the Y direction. That dot in the Y direction, because the thumbstick is actually two different axes, does not always fall exactly in center. Now I want to emphasize, we have very high quality thumbsticks put in the controller that have an extremely tight variance. But still, even then, you might consider putting a dead zone, a very small dead zone, to account for the fact that this dot doesn't always go back to 100% center, and that's fine. This is expected with mechanical controls. There's always going to be some degree of dead zone that we need to implement. Or you may not need to implement, you may be fine with it, but perhaps you want to correct that behavior if you're noticing for any reason it's affecting flight on certain types of aircraft. So we have documentation on the Yawman website, and on that website you'll see that we have some default recommendations about 2 to 5% dead zone for the X and Y on the thumbstick, as well as the axis for rudder. So going back to Microsoft Flight Simulator, we are going to implement approximately 2% for 2 to 5% for the dead zone for the X and Y. So it can be pretty tight because this thumbstick centers pretty aggressively. And you'll notice, and it's very hard to see, and let me exaggerate the dead zone here so you can see what's going on. So you'll see that when I create a really large dead zone, any time the dot is in here on this flat plateau, it's going to ignore that input essentially, and it's going to treat it as 0, treat it as center. So the x-axis is the input coming from the controller. The y-axis is the actual output that the flight simulator is going to see and how your airplane is actually going to respond. So we do not need that much dead zone, but I just wanted to exaggerate it to show that effect. We find that a dead zone of approximately 2 to 5% should be sufficient. And it's going to be a little touchy using the mouse right here. And you'll see that when I go back to center and I let go of the stick, you'll see that the dot is falling on that plateau, which is exactly what we want, because when it's on that plateau, it's effectively going to treat the input as 0 and keep it logically centered. When we designed the Arrow, we did not, in the firmware, hide anything. We wanted to make sure that all of the controls were completely transparent and leave the calibration and configuration up to you, so you can choose the behavior you want. Now the rudder, which is going to be the triggers right here, and you can see that these actually center. And what we are going to do is this will actually have a bit more centering variance than the stick, and that's expected. But we can still correct that with dead zone or sensitivity. So the dead zone, you can see it does drift off center just a little bit when I let go. And so a dead zone of maybe about 5% is going to be sufficient here, and that should capture that input. Maybe you'll find you need to do more, and if you're finding that your rudder is behaving wildly outside of that center, you probably need to do a firmware level calibration, which is documented on how to do, and that'll be a separate video. But you can do the dead zone. Another option you can do as well, and this is something I kind of like to do, is I like to take down the sensitivity a little bit. And let me exaggerate these as well so you can see what exactly is going on. So when I take off sensitivity, what it does is it takes this line and essentially turns it into this S-shaped curve. So that when I press an input on my axis, it's going to soften that input and dampen it down a little bit so that it's slower to react on small changes. But the moment I go into the extremes, that's when it's going to do it's going to consider that to be a much larger change. So that is another option as well, is you may use a dead zone. You can also change the sensitivity if you find that lowering the sensitivity feels better. And there are other tools right here. So let me take the sensitivity. Let me remove all of the sensitivity and put it back to neutral, 0%. But there are other tools you can do as well. Like so we talked about sensitivity and dead zone. You can also bias the neutral. So if for any reason you want to configure it to be more left or right, that is another thing you can configure. You can also change the dead zone on the extremes, and this is not something you should have to do with this controller, but you do have that option of essentially dampening the extreme zones so that the whole input becomes very softened across the board. I barely touch this control, but just know it's there. So after you're done, it'll prompt you to create a new profile, and you can just give it a name, such as I'm going to put Tom's profile, and that'll save the sensitivity as a separate profile. The profile will also include whatever other custom actions you want to implement the axes and buttons for flight controls. This is a video we will talk about separately. But that is it, folks. I hope that this video helped you, and again, it's how you change dead zone and sensitivity and all of those other response curves is completely up to your taste. Thank you again, and I will see you in the next video.